Welcome to another week of Forecast Lab. The cumulus clouds are looking a lot less vertical, and you can see they look a little bit more pancaked than what we've seen over the past week. And even a few patches of altocumulus up there at about 8,000. Let's take a look at the sounding in effect right now and see how things look on the charts. There you go, that's a good proximity sounding. And we see the reappearance of the cap right there. You can see how that red line bends to the right as you go up, and that puts the cap at about 5 to 6,000. And above that, yeah, you can see that altocumulus up there at about 10,000 feet. So we've got some decent lapse rates above the cap. This is not the typical kind of environment where we have warm air aloft and cold air at the surface, giving us the stratified clouds. This is just a layer of mid-level warm air and then cold air above that, so things are still unstable, and that's reflected in the CAPE values there. Moderate values of about 1,000 to 1,500. And some decent moisture in the lowest 3,000 feet of the atmosphere, so that'll at least get our parcel to the right of the temperature line. We can see that the atmosphere is a little bit more sheared due to some upper tropospheric shear. You can see the storm relative velocity there, pushing out to about 50 knots. However, low-level shear is still on the low side. And then we got to look at total shear. Yeah, so we can see that the 0 through 6 kilometer shear is pretty low, and it's really above 6 kilometers where the shear really becomes important. And I think it's important that when you're only considering the 0 through 6 kilometer layer, which is very common in a lot of books and journals, you're going to be missing a lot of detail. If you take the entire cloud into account, you get much higher values. And that's probably more representative of what we have right now, because the cloud extends well above 6 kilometers, and that's going to go all the way up to about 200 to 300 millibars. All right, let's start out by looking at our dynamics. Go back to the current time, and there's what we got right now. Cutoff flow over Texas, another cutoff flow between Hawaii and California, and the main belt of prevailing westerlies coming onto the British Columbia coast and crossing Canada. So we've actually shifted into kind of a summertime pattern. Quite a change there. And let's just take a quick look at, I should probably point out this jet here. That's probably like a segment of the polar front jet. We can kind of consider it that. Don't get a sounding. And we'll take a quick look at what's expected over the next few days. Looks like the upper level low weakens and shifts into Arkansas and Tennessee by later this week. A very slow drift, and then the low off of California approaches the California coast. So we should see deteriorating weather towards the weekend. Looks like mostly around the central coast in San Francisco. Then after that, well, we're not building the ridge in quite as aggressively as some of the models were indicating, but it will be parked directly over Texas, and that probably means some very warm weather for the southern plains. And that'll keep storms kind of shut down. Then going into next week, much the same for the beginning of the week. Still keeping those prevailing westerlies up to the north. And let's see, the cutoff flow kind of opens up a little bit. And not quite. Still looks like a lot of ridging in the central plains. So yeah, it's not going to be until maybe a week and a half before we open up that strong flow over the plains. So it looks like we're finally getting it around the 8th. That's really a ways out. Anyway, so yeah, looks like some dull weather ahead for the next 10 days. Well, that'll probably give us a chance to review some of the fundamentals and maybe touch on some basics. Maybe we can do some tutorial type stuff over the coming week. There's a look at our surface map for this afternoon. This low pressure area came from Texas. It came from a convective cluster, kind of an MCV. It looks like it's moved north and developed some baroclinic characteristics. I can definitely see a temperature gradient between Kansas and Illinois there. So I'm kind of carrying this as a small-scale frontal system. And then going down into the southeast U.S., we can see a mix of boundaries. Main convective cluster there in Louisiana, and there's some more scattered around Alabama and off the coast of South Carolina. And that's producing a variety of small-scale outflow boundaries. Got what looks like a decaying front in the Appalachians, and then going to the north, looks like a new Alberta Clipper, or actually this would be a Pacific system. Looks like it's probably moving west to east across the prairies and bringing some cold air into the Dakotas, Saskatchewan, and Montana over the next day. And we're still generating some polar air up there in Quebec, lots of 30s and 40s and 50s, but it's nowhere near as strong as it was a couple weeks ago. So the presence of any organized low on the Great Plains should catch our attention, especially in May. See, notice how the flow is backed to the northeast of that low. That's going to elongate your hodographs. And anywhere east of the low, even down in Missouri, would have some potential. So we've located the center of that low in southwestern Iowa. So drawing our isodrosotherms, I get a pattern kind of like that, and that shows a moisture axis right there around the Des Moines area. It looks like a secondary axis maybe through here in northeastern Iowa, and maybe a little spur kind of like that. So where that intersects the warm front, that's an area I would look for enhanced severe weather potential. And we can kind of see some dryness in this area here. That probably indicates that maybe some outflow has affected that region. So let's take a look at the radar animation over the past evening and see what has happened up there. So here's what things looked like yesterday in the Central Plains. There's Kansas, Nebraska, Iowa, and Missouri. And we see numerous cells down to the south indicating uncapped air. Now keep in mind at this time yesterday that low was down in Texas and it moved into the Central Plains overnight. So moving forward, this is around dusk, a couple of loosely organized storm areas moving through Iowa northward. And then we lose the solar heating, get into nighttime, there's about midnight, and we did have an MCS move up north with that low. And we can see that MCS swept into southwestern Iowa, tail end through the Des Moines area, and it hasn't had much effect on the area east of I-35. And then in the morning, this is about 9 to 10 a.m., looks a lot of it's probably elevated at this point. And then we see a reduction in coverage and then new convection coming together about noon. And it looks uncapped once again. There it is. So no wheel marked boundaries, nothing like that. But it does look like the heavier convection affected western Iowa. And that brings us to the visible imagery. Starting out this morning about 10 to 10:30, a lot of debris in the western part of the state. Looks like there's a reduction in that debris cover, and then we see out in the sunlit areas, lots of new convection gets going. And that brings us to the current time. There we are right there. It's kind of formed up into a series of lines, kind of like that. So the atmosphere is definitely uncapped. And we're going to see a lot of cell competition today. And I think the model soundings give us a pretty good playbook for what's going to happen this afternoon. These objective analyses have gotten very sophisticated over the years, integrating data from a wide variety of sources. So for a first look, I think they're very useful. Now we can see convection has already broken out over Illinois, so it's helpful to dial this back to an earlier run. We're going to go back to 16Z and see what the environment looked like over Iowa. All right, so let's bring up a sounding, maybe right here around Des Moines. Yeah, you can hear the fan going on that computer down there. All right, yeah, total lack of capping. There you go. If you want to see what an environment with no cap looks like, just bookmark this link here, and there you go. It does look like there is some warmer air aloft, centered on about 20,000 feet, so that's going to suppress your cape just a bit. But down below it, some decent lapse rates, and that'll give you good initial partial accelerations. Also a fairly decent layer of moisture extending up to about 3,000 to 4,000 feet. Little dryness above that, but that's probably enough to give us some good low LCLs, which will be favorable for convection that does get going. But I guess what cape we do generate is going to be a little iffy. So depending on what numbers you use, you can see the mix layer is way down there at 500 joules per kilogram. Other values up to about 1,500 to 2,000. So it depends on what kind of parcel you get. But storms are going to be everywhere pretty quickly. So I would probably lean this toward the low side of that spectrum. We do have some storm relative shear there, getting some SRH, and you can see that the entirety of the sounding is out in this quadrant, which is very unusual. So that means cells are going to be moving to the northwest today. Deviant motion will be directly north at about 30 knots, according to the Sharpie algorithm here based on the bunkers method. And then weak cell motion will be to the northwest. So if one was to be out chasing, they would have to be prepared for this kind of unusual movement, and that's going to also rotate the storms. So instead of a supercell looking like that, which you tend to see in books, trying to draw the heavier rain core, it's actually going to be twisted around. Yeah, kind of looking like that. So your hooks are going to be facing to the right, assuming that we had any hooks today. I mean, there's probably an outside chance of maybe some rotating storms. So you're going to be looking at the eastern side of the cells for that kind of activity. Storm environment, let's check that out. That shows the storm relative quantities. And they do look, I would say, moderate all the way up at all the different levels. So nothing too great, nothing bad. And then we got to factor in the total bulk shear, which is not shown on this. We have to look in this section of the diagram, and those values are, again, marginal. So cloud layer shear, about 25 knots. That's not great, and that's going to put you in the HP end of the spectrum. So numerous cells, weak shear. That's going to mean a lot of outflow of storms. And the only thing that's keeping things from totally going outflow is the lack of dry air aloft. You can see that the D-cape is very low. So you may get a little balancing of the cells, maybe not so much undercut, but you will have the tendency to precip down into the updrafts a little bit. Not totally, but the updraft, downdraft cell spacing is going to be a little bit reduced on a day like today. So what's going to happen today? Let's take the model up to 18Z and just get an idea what's going to happen. Looks like numerous cells. Looks like the cells just kind of propagate to the north there, and things start to clear out in Iowa by this evening. And Great Plains looks pretty quiet. And we'll shift things up there to Minnesota. Yeah, it looks like things move on up into the Minneapolis area around 7:08 p.m. Let's check out those proximity soundings out ahead of this activity. And we can see again the atmosphere is uncapped, so numerous cells. And just a small bit of storm organization here. Bulk shear is about 25 to 30 knots there. And just a minuscule SRH there. So that's given us about 50 to 100. Not great, but... And looks like moderate capes there. 1,000 to 1,500, so nothing to write home about. Storm motion to the north, and I guess any severe weather is just going to boil down to mesoscale accidents, wherever we happen to get boundaries, a storm with no cell competition, and you would have to be tracking the radar from minute to minute. All right, let's look at patterns over the next week, and we'll use the European model. And I've used dew point here so we can track the moisture. So starting out, we know that that frontal system is there in the eastern plains and on the west side, bringing in that dry air from the high plains. Going forward later in the week, that low pressure area looks like that moved up to Lake Superior there around Wednesday, and a little bit more cyclogenesis around Missouri and Kansas. However, there's a big change coming up. Cold front moving into the Dakotas and northwesterly wind. And watch what happens later in the week, Thursday and Friday. That cold air comes down into Wisconsin, Iowa, leading edge filtering all the way down into the central plains. And then by Saturday and Sunday, it's already infiltrated Texas and Louisiana. So the leading edge is somewhere down here. And a little bit of upslope flow developing there in Nebraska. However, this is going to kind of shut down the Gulf. Notice how the winds are out of the east-northeast down there. And that's going to push the moisture mostly into Mexico. So this is Sunday, and let's go into Monday and Tuesday, first week of June. Well, starting to open up the Gulf there on the 1st. So this is starting to look like more of a seasonal pattern here with south flow across all of the Great Plains. And notice how we go from 70s dew points there on the coast to 20s and 30s in the Panhandle. So this is the return of moisture. And if we move forward, you can see that moisture infiltrate Texas, building up the I-35 corridor for the 3rd and 4th. So probably some storm chances coming back for this area around the 3rd. And yeah, the Gulf is pretty much wide open for the first week of June. And you can see those 70s flowing north. Now it looks like there's a kind of an absence of a dry line pattern. You notice the dew points have not fallen off very much in New Mexico. Bringing up 50s and 60s dew points up in that region. And to me, that kind of hints at a very moist profile. Well, we can't bring up a Skew-T on the ECMWF, but let me go over to the GFS. Yeah, you can see the GFS going for a very similar situation. There's a Skew-T for Lubbock on the 4th, and looks like lots of tropical air. Moist all the way up. Weak lapse rates and poor wind shear. So this is not much of a springtime pattern. This is more of a summer pattern. Almost like a monsoon pattern. And it looks like only late in the period, if at all, around the 8th or 9th, that we start developing cyclogenesis on the plains and the EML gets reestablished. And this is interesting. GFS going for a hurricane on the 8th and 9th. Well, that'd be a tropical storm. And this is interesting. Looks like a large tropical storm making landfall in Louisiana on the 8th. Of course, this is 324 hours out, but I've seen the previous GFS models kind of going for something like that. And that goes inland and probably lots of rain in that region, assuming that happens. And it may not, because that's over 300 hours out. The models tend to be very erratic that far out with such small systems. And tropical storms are not really what we see in early June. Okay, and we'll just wait and see on that. Well, I believe that is all we have for today, so we'll go ahead and wrap this up. I appreciate you watching the videos and especially for your support. Thank you for joining us, and we will see you tomorrow. Bye-bye.